Hey guys, welcome back to my YouTube channel. In this video, we continue our quest on percentage error. So, in our previous video, we started on using place values, that is tens, thousands, and decimal places. We use decimal places and also the unit to calculate our percentage error. This video will look at another example, that is the length of a field is measured as 500 meter. Find the percentage error of the length if the room is measured to nearest 10 meter, the nearest one significant figure, and also the nearest one decimal place, that is the tenth of the. So we already have the length, the true value is 500 meter. Right. So what we didn't know the so to the nearest 10 meter, that is tenth, right? To the nearest tenth. So we need to find the range. One way I try to to explain the range to my is the possible place whereby where you still approximate it back and you get back this when you approximate back. So what I like to do to get this is the 10th meter, or whatever we're asked to where we're asked to estimate to, like exactly where we're find the percentage to. So I do 10 divided by 2. Whatever it is 1 meter divided by 2. So that'll give us 5 meter. So now to get the range now, you subtract this from, you add and subtract this. So that's plus or minus 2. Sorry, of 5. So you'll be having 495 meter to 505 meter. So that's the error. But this is not like this is particularly the error. But this is not like a formal way to get a error. So the now formal way to get error is now to use the true value minus any of this, because here will give you, the idea is that if you approximate this any number between these values, if you approximate them, you can still get 500. If you are approximate to the nearest tenth, in this regard to the nearest tenth, so because to give us 500. So when you have this now, from this to this, you subtract 500, 495, to get our error. Our error now is 5 meter. Yeah, so you can just go ahead using percentage error formula. Percentage error formula is error over true value times 100. Those are 5 over, those are true value 500 meter times 100. Our answer is 1%. So in instance whereby we are asked to find the nearest, when it's measured, we should find percentage when it's measured to the nearest one significant figure. One significant figure. One significant figure. So 1 SF. As they will imply. So this regard, one significant figure is the first absolute number that is not first number that is not decimal from the left hand side. That's 5. So that's like occupying the 100th position. That's 100. 100. So now to get the range, like I said before, you can just divide what they ask you to do divided by 2, or this is 500. The significant figure is here, just place a 1, then you add your zeros to the point of the last zero and last decimal place 1 2, now divided by 2, then you get 50. So now to get a range now, that will be 500 plus or minus 50. So that will be 500, sorry, that will be 452, 4 to 550. Because in this range, if you are trying to approximate to the nearest one significant figure or 100, you will get your 500 back. So that's the idea. So now to not get the error, the usual way. One of the way I get my errors is this: just divide it and just get my. But the usual way is you are now to subtract any of these now using the absolute. You should get your 50 back. Let's not get a percentage error now. That'll be 50 all over your true value times 100, and that will give us 10. Strike this out, so that's your 10%. Right. The last question, when we have to do it to one decimal place, as the 10th. Sorry, 10th. So like I said, what I like to do is this 500. So one decimal place will be 0. So you place a 1 where your value is in this dot 0. So that will be 0.1 divided by 2. That will give us a 0.05, right? Divide this by 2. Use your calculator if you check this. Get that. So when you have this as a result, now to get our range now, our range will now be 500 plus or minus 0.05, right? So if you subtract this, you should be having 499 point, this should be 95, right? Yeah, 95 to, yeah, 4, no, 5, 0.05, yeah, in this regard. So when you have this in this, if you approximate it to the nearest to the nearest one decimal place, you get your 500.0 back. So that would idea. So we have our error to be 0.05, right? So now to just calculate it for the legal means squaring, I just have 500.05. That'll give us a. Note this can be plus or minus, right? But either way, but since it's absolute, it's most likely plus. Then you use your formula, percentage over percentage error is equals to error 0.05 over 100 times 1000. Sorry, over 100. So over 500. So multiplying this now, this will give us 1, 2, that will make us 5. 5, I'll say 5. So you still have 0.01% as our error. So in the next video, we'll be showing different other examples of possible questions in percentage error, one of which is calculation, and also a bonus question. Do well to check it out. Percentage error involving calculations of questions. See you in the next video. Thank you very much.